At -40 degrees, exposed skin can fail in minutes, equipment stiffens, breath turns to ice, and help is too far away to matter. Yet Arctic oil rig workers operate in those conditions every day, without immediate rescue, without the option to walk away. By the end of this, you will understand how that is possible. Not through heroics, not through luck, but through layered systems that manage cold, distance, fatigue, and risk in ways most people never see. The first enemy is not the ocean. It is heat loss. The human body survives by maintaining a narrow internal temperature range, but Arctic air strips that warmth away through conduction, convection, and evaporation. Steel amplifies the problem. Metal decks pull heat from boots. Handrails drain warmth from gloves. Wind accelerates the process. Standing still becomes dangerous. But the solution is not simply thicker clothing. More bulk can restrict movement, and restricted movement creates mistakes. Therefore, the system relies on controlled layering. Each worker wears a sequence of garments designed to trap still air between them. The goal is not insulation by thickness alone, but insulation by structure. Thin, breathable layers closest to the skin move moisture away. Insulating layers trap air. An outer shell blocks wind and moisture. If one layer becomes damp, it can be replaced without dismantling the entire system. Moisture is a silent threat. Sweat cools rapidly in sub-zero air. A damp sleeve can turn into a freezing band within minutes. Workers do not dress only for the temperature, they dress for the task. If a job requires heavy exertion, they begin slightly cool to prevent sweating. They regulate heat by opening vents in outer layers, not by removing protection entirely. The principle is simple. Stay dry, even if it means feeling colder at first. Hands present a different challenge. Fine motor tasks are common on a rig. Valves must be adjusted, tools secured, connectors aligned. Thick gloves protect against cold, but they reduce dexterity. Bare skin is not an option. Therefore, gloves are layered as well. Thin liners allow brief exposure when precision is required. Outer gloves provide insulation during transit. Tasks are structured to minimize the time hands are exposed. Tools are modified with larger grips. Controls are designed to be operated without removing protection. Breathing creates another problem. Inhaling extremely cold air irritates airways. Exhaling releases moisture that freezes on fabric and equipment. Face coverings are not just for comfort. They pre-warm incoming air and reduce frost buildup. Workers manage frost accumulation on protective gear regularly, brushing away ice before it adds weight or reduces flexibility. Cold affects more than the body. It alters materials. Lubricants thicken, seals contract, electrical systems behave unpredictably. Equipment that functions normally in temperate climates responds differently at -40. But operations do not rely on hope. Therefore, machinery is selected and maintained with cold behavior in mind. Fluids are rated for extreme temperatures. Components are shielded from direct exposure where possible. Systems are tested in low-temperature conditions before deployment. Even with preparation, mechanical resistance increases. Moving parts require more force. Starting engines takes longer. Therefore, procedures account for delay. Warm-up periods are extended. Redundancy is built into critical systems. If one unit fails to respond, another can assume its role. No essential function depends on a single mechanism. Isolation magnifies every issue. In remote Arctic operations, external rescue is not immediate. Weather can ground aircraft. Ice can block marine access. Medical facilities are far away, but this does not mean there is no support. Therefore, the rig itself becomes a self-contained response system. Medical training is distributed among crew members. Emergency equipment is stored on site. Communication systems connect the rig to coordination centers, even if physical evacuation is delayed. Time is structured differently in extreme cold. Exposure duration matters as much as temperature. Workers rotate between indoor and outdoor tasks. Shorter shifts limit prolonged exposure. Break areas are heated and positioned strategically to reduce travel distance in storms. Schedules adapt to weather forecasts. If conditions worsen, non-essential tasks are postponed. Wind introduces instability. Gusts can affect balance and visibility. Therefore, movement protocols are strict. Handholds are used consistently. Safety lines are attached when working near edges. Footwear is selected for traction on icy surfaces. Walkways are treated and maintained to reduce ice buildup. Even so, caution is constant. Every step is deliberate. Darkness compounds risk. Arctic regions experience extended periods with limited daylight. Artificial lighting becomes essential, but light can reflect off snow and ice, creating glare. Therefore, lighting systems are positioned to minimize shadow zone. Personal headlamps supplement fixed lights. Workers adapt their pace to visibility. Fatigue is another layer of danger. Cold demands energy. The body burns fuel to maintain warmth. Tasks require focus under physically stressful conditions. Therefore, nutrition is not casual. Meals are structured to provide sustained energy. Hydration is monitored, even though thirst decreases in cold environments. Dehydration can impair judgment. Warm beverages support both hydration and morale. Morale is not a soft concept here. Isolation and harsh weather can erode mental resilience. Therefore, routines are maintained. Communication with family is facilitated when possible. Shared spaces encourage social interaction during off hours. Psychological stability supports operational safety. One overlooked factor is sound. Wind over steel structures creates constant noise. Machinery adds another layer. In cold air, sound travels differently. Verbal communication can be difficult. Therefore, hand signals and standardized gestures are practiced. Radios are used with backup batteries protected from cold. Communication protocols reduce ambiguity. Midway through any shift, complacency becomes a risk. The first hour feels sharp and focused. The body reacts to cold with urgency, but prolonged exposure dulls perception. Fingers may still move, but sensitivity decreases. The mind adapts to discomfort, and that adaptation can hide danger. Therefore, routines include deliberate self-checks. Workers inspect each other's gear for frost buildup. Unsecured straps expose skin. They monitor speech clarity and coordination. Subtle changes can signal cold stress before it becomes visible. Hypothermia does not begin with collapse. It begins with mild confusion, reduced fine motor control, slower reaction time. On an oil rig, even a small delay can create cascading consequences. Therefore, work is rarely solitary. Teams operate in pairs or groups. One person performs the task, another observes. Observation is not passive. It is an active safeguard against silent deterioration. Steel structures contract in extreme cold. Alignment shifts slightly. Surfaces that were stable in warmer conditions may behave differently. Therefore, inspections increase in frequency during cold snaps. Bolts are checked, seals are examined, walkways are cleared more often. Preventive maintenance intensifies when the environment becomes more hostile. But cold alone does not define the Arctic platform. The ocean beneath it remains in motion. Ice can accumulate along edges and around structural supports. Wind-driven spray freezes instantly. Therefore, ice management becomes continuous. Crews remove buildup to prevent excessive weight and imbalance. The process is methodical. Sections are cleared in sequence. Safety lines are secured before work begins. Visibility can deteriorate without warning. Snow carried by wind creates near whiteout conditions. Depth perception changes. Therefore, navigation paths are marked with high contrast indicators. Workers memorize routes between key areas. Movement during low visibility is restricted to essential tasks. Predictability reduces confusion. Despite layers of protection, the body still loses heat. Core temperature remains stable only through constant regulation. Therefore, activity cycles are carefully planned. High exertion tasks are grouped. Workers avoid prolonged inactivity outdoors. When waiting is required, it happens indoors or within sheltered zones. Standing idle in -40 air drains heat rapidly. Inside the rig, climate control maintains habitable conditions, but transitions between warm interiors and extreme exterior air introduce another challenge. Rapid shifts can create condensation inside clothing. Moisture can freeze once back outside. Therefore, clothing adjustments occur gradually. Workers pause in transitional spaces to equalize temperature before returning to full exposure. Hydraulic systems stiffen in low temperatures. Moving a valve or lever may require more force than expected. Therefore, operators anticipate resistance. They avoid sudden jerks that could damage components. Slow, controlled movements preserve both equipment and stability. The deeper layer most people overlook is decision-making under environmental stress. Extreme cold narrows attention. The body prioritizes warmth over complex reasoning. Therefore, procedures are standardized. Checklists reduce cognitive load. Tasks follow predefined sequences. Deviating from structure increases risk. Every action has a countermeasure built into it. If a worker must climb, there is a secondary attachment point. If machinery must operate continuously, backup systems stand ready. Redundancy is not optional in isolation. It is the only buffer against delay. There is also a threshold at which operations shift from efficiency to preservation. Productivity matters, but survival overrides output. When wind exceeds certain levels, exterior work slows or pauses. When ice accumulation reaches critical levels, clearing becomes the priority over production. The hierarchy of tasks adjusts dynamically. Power supply must remain stable. Heating, lighting, and communication depend on it. Therefore, generators and backup units are maintained aggressively. Fuel lines are protected from freezing. Monitoring systems track performance constantly. An interruption would affect not just comfort, but safety. Living quarters are designed to conserve energy. Doors seal tightly. Windows minimize heat loss. Air circulation balances warmth and ventilation. Overheating is avoided because excessive indoor warmth can make outdoor re-entry more stressful. The goal is equilibrium, not luxury. One of the most powerful structural insights is that no single measure ensures survival. It is the layering of systems that creates resilience. Clothing layers manage body heat. Equipment layers manage mechanical function. Procedural layers manage human error. Social layers manage psychological strain. Remove one layer, and the others bear more weight. Workers adapt behavior continuously. Movements become economical. Gestures are deliberate. Speech is concise. Every unnecessary action consumes energy that the body must replace. Efficiency becomes instinct. The ocean remains a constant reminder of isolation. Falling into freezing water would overwhelm even the most prepared individual. Therefore, barriers, guardrails, and harness protocols are strict. Edges are treated as high-risk zones. No one approaches them casually. Storms can trap the crew on site longer than expected. Therefore, supplies are calculated with margin. Food, medical resources, and fuel are stocked to account for delay. Isolation is anticipated, not feared. Communication with the outside world maintains situational awareness. Weather updates inform scheduling. Technical support can advise remotely, but even communication systems face strain in extreme cold. Therefore, backup methods exist. If one channel fails, another compensates. Mental resilience is reinforced through predictability. Structured schedules create stability within chaos. Regular meals, consistent sleep cycles, and defined shifts prevent disorientation. In environments where natural cues are limited, routine anchors perception. Sleep itself becomes strategic. Rest must restore cognitive clarity. Sleeping quarters are insulated from noise and vibration as much as possible. Workers prioritize rest because fatigue magnifies cold stress. In the final layer, the most important element is acceptance of limitation. Extreme environments impose boundaries. Ignoring them leads to failure. Respecting them leads to adaptation. Arctic oil rig workers operate not by defying the cold, but by negotiating with it. They do not eliminate risk, they manage it. They do not overpower the environment, they design around it. The absence of immediate rescue does not mean absence of support. It means support is internal, structured, and deliberate. The reason operations continue at -40 degrees is not bravery, it is system intelligence. Every layer anticipates weakness. Every protocol compensates for human limitation. Every adjustment acknowledges the environment's authority. When viewed from a distance, it appears impossible. Steel against ice, human breath against Arctic wind. But inside the structure, nothing is left to chance. Heat is trapped. Movement is controlled. Redundancy absorbs failure. Community offsets isolation. It works because it is built to work in that exact hostility. Remove the cold, and the system seems excessive. Add the cold, and the system becomes essential. Operating in -40 with no immediate rescue is not about surviving a single moment. It is about maintaining balance hour after hour, shift after shift, storm after storm. It is about understanding limits deeply enough to stay just inside them. That is how it is possible. The platform does not fight the cold. It negotiates with it every hour. Steel contracts, wind shifts direction. Spray freezes mid-air. The structure absorbs all of it. Workers adjust constantly because rigidity in this environment breaks faster than metal. One overlooked factor is vibration. Machinery operating in extreme cold transmits different resonance through steel frame. Metal becomes less forgiving. Microfractures are harder to detect by sight alone. Therefore, inspection teams rely on sound, on touch through insulated gloves, on routine pattern recognition. They know how equipment normally feels. When it feels different, they investigate. Movement between interior and exterior zones follows a controlled rhythm. Doors are never left open casually. Airlocks minimize heat escape. Small details matter. A single door left ajar during a storm can change interior pressure and temperature balance. Therefore, transitions are disciplined. Cold also changes time perception. Tasks feel longer. Fingers feel slower. Therefore, pace is standardized. Not rushed, not hesitant, consistent. Predictability reduces stress. Tools are staged before deployment. Workers do not wander searching for equipment in -40 air. Everything is prepared inside, verified, secured, and then carried out with purpose. Exposure time is minimized through planning, not speed. There is no improvisation for critical operations. Creativity belongs to design phases. Execution follows protocol, because cold punishes uncertainty. Communication shifts in tone outdoors. Speech becomes direct. Words are shortened. Hand signals take priority when wind swallows sound. Confirmation is repeated. Clarity replaces casual conversation. Food consumption increases during extended cold cycles, not out of indulgence, but necessity. The body burns more energy simply to remain warm. Therefore, meals are balanced for sustained release. Warm fluids assist internal temperature regulation. Dehydration is monitored even if thirst is suppressed. Inside sleeping quarters, lighting mimics natural cycles when possible. Artificial day and night patterns preserve circadian rhythm. Without them, fatigue and confusion escalate. Environmental psychology becomes part of survival. If you are finding value in this breakdown of how extreme systems actually function under pressure, take a moment to support the channel. It helps keep these deep analyses coming. Now consider maintenance during a cold snap. Exterior bolts may require retorquing. Rubber components stiffen. Electrical cables lose flexibility. But the solution is not brute force. Therefore, maintenance schedules tighten. Preventive checks become more frequent. Minor irregularities are corrected before they compound. Weather forecasting becomes a central operational tool. Wind shifts influence crane operation. Ice accumulation alters weight distribution. Therefore, decisions are not reactive, they are anticipatory. Crews prepare before conditions peak. Cold air holds less moisture, but interior humidity remains a factor. Breathing, cooking, washing, all add vapor. If ventilation is too low, condensation forms. If ventilation is too high, heat escapes. Therefore, balance is constant. Systems are calibrated continuously. Mental discipline is reinforced through repetition. Workers rehearse emergency protocols during stable periods, not because crisis is imminent, but because rehearsal builds automatic response. In -40 degrees, hesitation costs more than time. The platform functions as a closed ecosystem. Waste management, water purification, energy distribution, all operate internally. Isolation demands autonomy. Every subsystem must perform reliably without external intervention. During prolonged storms, exterior work may be suspended, but suspension does not equal inactivity. Interior systems are reviewed, equipment is prepared, logs are updated. Efficiency is maintained even when visibility drops to near zero. Cold impacts batteries significantly. Power storage loses efficiency. Therefore, critical batteries are insulated. Spares are stored in temperature-controlled compartments. Power management is deliberate. Exposure management extends to facial skin. Frostbite risk increases with wind. Face coverings are adjusted frequently. Workers monitor each other's skin tone. Pale patches signal early freezing. Intervention is immediate. Inside control rooms, monitoring screens display environmental metrics. Wind speed, surface temperature, structural stress indicators. Data informs action. No assumption goes unverified. If this perspective on system-level survival is shifting how you think about extreme work environments, consider subscribing. These environments reveal more about human design than comfort ever does. Now focus on logistics. Supply deliveries are planned around weather windows. Timing is strategic. Delays are accounted for in storage capacity. Overdependence on punctual arrival is avoided. Water systems are insulated and heated to prevent freezing. Flow rates are monitored. Stagnation is avoided. A frozen pipe is not just inconvenient, it compromises habitability. Fire risk behaves differently in cold climates. Heating systems increase electrical load. Therefore, fire suppression equipment is accessible and tested frequently. Safety does not relax simply because the primary threat is cold. Sleep cycles are protected aggressively. Fatigue lowers core temperature regulation and decision-making ability. Shift lengths are designed to prevent burnout. Rest is considered operational support, not personal indulgence. When ice builds on railings or ladders, removal is prioritized before it becomes structural hazard. Teams rotate to prevent overexposure during clearing tasks. If you appreciate content that dissects the mechanics behind survival, rather than glorifying it, support the channel with a like. It signals that this level of depth matters. Now consider psychological adaptation. Extended darkness alters mood. Therefore, communal spaces are intentionally active during off hours. Conversation, routine activity, shared meals, these stabilize perception. Noise inside the rig never fully stops. Machinery hums continuously. Workers acclimate, but they also create quiet zones for recovery. Mental recovery supports physical resilience. Emergency drills simulate equipment failure during peak cold. Teams practice response in full gear. Muscle memory reduces panic. Hierarchy remains clear. Decision authority is defined. In emergencies, ambiguity wastes time. Clear structure prevents confusion. The most overlooked truth is that survival is rarely dramatic. It is procedural. It is disciplined repetition. It is adherence to systems designed long before the temperature dropped. The reason operations continue in -40 is not because individuals are fearless. It is because systems remove the need for fear-driven decisions. If this insight into layered operational survival is valuable, Stay with the channel. There is more beneath the surface of extreme environments. Cold will always challenge human physiology, but adaptation turns exposure into routine. This is how Arctic oil rig workers operate in -40 degrees, with no immediate rescue, through structure, through anticipation, through layered defense, through disciplined execution. The environment does not change for them. They change for the environment. Cold reshapes behavior long before it reshapes steel. When air reaches -40 degrees, even simple movements become strategic decisions. Breathing slows, muscles tighten, the margin for distraction disappears. Yet the platform does not freeze into paralysis. It continues to function because its operation is engineered around limitation, not comfort. Every shift begins with assessment, not dramatic, not theatrical. A quiet evaluation of weather patterns, wind direction, surface conditions, system loads. The goal is alignment. Tasks are aligned with conditions. Exposure is aligned with necessity. Nothing is random. The environment constantly tests weak assumptions. Metal that behaved normally at higher temperatures now responds differently under load. Therefore, weight distribution is monitored more frequently. Structural stress is tracked. Expansion joints are examined for contraction shifts. Cold air increases brittleness in certain materials. That brittleness influences maintenance schedule. Components are replaced before visible damage occurs. Waiting for visible failure is unacceptable in isolation. Outside, walking is deliberate. Boots compress snow and ice differently depending on temperature and moisture content. Workers adjust gait unconsciously over time. Steps shorten, balance widens. Hands remain near anchor points without gripping unnecessarily. Grip itself changes in the cold. Gloves reduce tactile feedback. Tools can slip more easily. Therefore, lanyards are attached to critical equipment. Dropping a tool in a mild climate is inconvenient. Dropping a tool in an Arctic storm can escalate risk rapidly. Wind is rarely constant. It shifts without warning. Gust patterns alter exposure angles. Workers instinctively turn their bodies to reduce direct impact. Protective hoods are adjusted in seconds. Reaction becomes reflex. But the deeper layer is not reaction. It is anticipation. The platform functions because each worker anticipates degradation before it becomes visible. Frost buildup begins as a faint sheen. That sheen becomes ice. Ice becomes weight. Weight becomes imbalance. Therefore, intervention occurs at the sheen stage. Inside machinery enclosures, temperature is regulated to prevent sudden shock to internal systems. Gradual transitions preserve mechanical stability. Abrupt temperature shifts can fracture components. Energy management extends beyond fuel. Heat itself is treated as a resource. Interior doors are compartmentalized. Sections of the platform can be isolated thermally. Heating is directed where needed, not wasted across unused zones. If you find value in this level of operational breakdown, make sure you are following the channel. These environments reveal how systems sustain human presence under extreme constraint. Cold also distorts sound. In open air, machinery noise travels differently. Workers learn to recognize subtle changes in tone. A slight irregular vibration can indicate thickened lubricant or ice interference. Time outdoors is measured not only in minutes, but in physiological tolerance. Workers check extremities discreetly. Numbness that lingers too long signals retreat. Pride has no place here. Visibility during storms compresses perception. Snow reduces depth cues. Edges blur. Therefore, navigation paths are intentionally repetitive. Repetition creates familiarity even when visual information is compromised. In isolation, communication delays are expected. External rescue is distant by design. Therefore, internal response capacity is emphasized. Medical kits are comprehensive. Crew members rotate through first response training. Confidence reduces panic. Food storage must withstand cold extremes without freezing solid. Provisions are kept in temperature-stable compartments. Balanced nutrition sustains metabolic heat production. Caloric intake is adjusted during prolonged cold exposure cycle. Hydration strategies are deliberate. Cold suppresses thirst signals. Therefore, drinking schedules are structured. Warm fluids support internal regulation and morale simultaneously. During extended storms, psychological resilience becomes operational currency. Workers engage in structured downtime. Mental disengagement from risk reduces cumulative stress. If this exploration into systemic resilience is changing how you view extreme labor environments, take a moment to support the channel. Engagement keeps this analysis possible. Consider emergency scenarios: a slip on an iced walkway, a mechanical jam, a temporary power interruption. None are treated casually. Each scenario has pre-established response sequences. No improvisation under stress. Even sleep is engineered. Sleeping quarters are positioned away from high vibration zones. Temperature gradients are controlled to prevent condensation near bedding. Rest restores cognitive sharpness, which restores safety. Lighting during prolonged darkness is calibrated. Excessively bright light strains eyes. Insufficient light increases errors. Therefore, balance is maintained intentionally. Isolation can distort perception of time. Days blend. Therefore, structured routines anchor the mind. Predictability is not monotony. It is stability. Maintenance teams operate with layered redundancy. If one tool fails, a backup is accessible within reach. If one worker experiences early cold stress, rotation occurs immediately. The most powerful structural insight is that risk is diluted through distribution. No single point carries the full burden of survival. Heat management, mechanical resilience, human vigilance, psychological stability, all share responsibility. When -40 degrees becomes routine, it does not feel normal. It feels controlled. And control in this environment is never accidental. If this deep dive into operational survival systems resonates, subscribe and stay connected. There are more invisible structures shaping extreme environments than most realize. Arctic oil rig workers operate not through defiance, but through alignment with environmental truth. Systems anticipate cold. Procedures anticipate error. Redundancy anticipates delay. There is no immediate rescue. Therefore, rescue is internalized. Preparation replaces reliance. Discipline replaces reaction. The environment remains unforgiving. The system remains prepared. That is how operations continue at -40 degrees, beyond immediate reach of help, through structure layered upon structure, quietly holding the line against the cold.